Welcome back to Smart Operator for Forestry. In the second lesson, we will discuss the impact of variables that determine machine energy intensity and what you can do with this information. Why are fuel costs important? History has some lessons. Price corrections have been dramatic, but eventually prices follow the rate of inflation, and the trend is for prices to rise higher and higher. When the price of fuel is low, at $1 per liter for example, fuel represents a smaller percentage of your operating costs, approximately 25% in this instance. But if the price were to increase to $1.50 per liter, fuel costs become a larger percentage of your operating costs, or approximately 40% in this case. Keep in mind that the actual percentage that fuel represents of the total cost varies depending on other elements, including ownership costs, maintenance costs, and labor costs. For example, if you own most of your equipment, your ownership costs are reduced. Thus, fuel can be an even higher percentage of your total operating budget. What happens when prices increase? If your harvesting contract is at a fixed price with no built-in fuel surcharge, you will earn less money. If you have been tracking fuel use by machine, you will have discovered that fuel, as a percentage of operating costs, varies by machine type. So an increase in fuel price from $1 per liter to $1.40 per liter, a 40% increase, raises the hourly cost of a fuel-efficient harvester by 4%. But for a more fuel-intense feller buncher, the hourly cost increase would be 6%. Understanding this relative difference in machine type costing is important when negotiating fuel surcharges in your harvesting contracts. Many factors drive energy intensity, or liters of fuel consumed per cubic meter of wood harvested. One of the most significant factors is the machine itself. The design of a machine determines its capabilities. Look at the feller bunchers on this slide. One is wheeled, and the other has tracks. Which one would you choose, and why? Consider the machine you did not choose. Would it work in your application? For what percentage of your operation, or ground type? Let's look at some examples. In this test, we had 3 skidders engaged in a conventional harvest. Under the particular site conditions, it was revealed that the John Deere 848 model outproduced the other machines, for a variety of reasons. But what is relevant to this discussion is that it also had lower energy intensity. Clearly, this machine was the winner in this instance, with higher productivity and 24% lower energy intensity than the TigerCat 615. The TigerCat 630 was cheaper to operate on an hourly basis, whereas the 6-wheel drive TigerCat 615 had a traction advantage. But it proved to be slower in turning around in the flat open terrain found on the test site. Your results will vary, as your operating conditions surely differ. Ask yourself, what are your operating conditions today? What will the conditions be in the future? Adapt your fleet to your changing needs. How do you choose your machines when you purchase or lease? Here are the top items. Dealer response time for service calls. Dealer reputation for ease of warranty claims. Brand reputation for reliability, ease of service, and operator familiarity. Perhaps you look for new technology that promises greater productivity and lower fuel consumption. Or, conversely, do you avoid new technology because it's unproven? Do you normally buy a particular brand and trust it? Or do you look elsewhere? Narrowing down your choices based on energy intensity can help you with your decision. Here are some factors that drive the energy intensity of an operation. Look at this list and consider which of these factors are within your control. It's important to understand the potential magnitude of these factors. For the factors in red, you can do something about the situation. For the other factors, in black, you have no influence and must instead account for the cost. Let's look at some examples. For the difficult task of harvesting blown-down timber, we choose to use the excavator-based Link Belt 290 with a Pierce grapple processor head. which can pick up horizontal stems and buck. This machine was compared to a purpose-built felling machine, the TigerCat 845C feller buncher with a hot saw. In this instance, the Pierce grapple processor was the right tool for the job, as it had higher hourly production and lower energy intensity. The link belt and Pierce GP head combo also recovered more wood than it broke, unlike the feller buncher. Consider specialty machines, or machines with capabilities that complement your usual logging equipment. How else could machines, such as the link belt and Pierce GP combination, be used to improve your operations when not cutting blown-down timber? When skidding loads on adverse slopes, the following happens. Speed decreases, particularly when approaching the machine's maximum grade ability. Fuel consumption decreases for favorable grades, but it increases for adverse grades. And the most important effect of grade, decreased production. The result? The cost per log delivered to the roadside goes up. Before deploying your equipment on the job, always discuss the best approach. Can the site be set up to skid the logs down slope? If so, make adjustments before burning the extra fuel. Sometimes, machine choice has little impact on energy intensity, and what determines the machine's consumption instead is the work being done. In this case, 2 loaders were operating in a log reload yard. Loader wait times for the trucks were the same, as the trucks were lined up and ready to go. Statistically, there is not a big difference in the performance of these 2 machines. This is an example of a smaller engine working relatively harder than a larger engine. In this case, the work and the fuel consumed were virtually the same. Because the smaller engine must work harder, it may have a shorter economic life and need more frequent maintenance, which are important factors to consider. If you anticipate your loader leading a hard life with a high duty cycle, consider purchasing a machine with a larger engine or a machine in a higher weight class. Alternatively, if you anticipate your loader being subject to a lower duty cycle, or if you value the lighter machine's portability, consider the smaller machine with its smaller engine. Maintaining your machine is critical in getting the best performance. A hydraulic tune-up is an essential maintenance activity for a machine such as a feller buncher that has a complex hydraulic system. It should be done every year. This corrective maintenance reduces fuel consumption, increases productivity, and lowers energy intensity, about 20% in the case of this particular feller buncher. In all, the repairs in this case study totaled $10,000. But with a big producing machine like a feller buncher, the payback on this maintenance investment can be in as little as 3 weeks' time. We all know that inexperienced operators can mean lost production and high fuel costs, as seen here, with 2 operators running identical machines on the same terrain. Getting your operator up to speed should not be left to chance. Although training can seem expensive, the payback can be substantial, as seen in this slide. Later in this course, you'll learn how to capitalize on the expertise of your equipment supplier and professional machine coaches. Energy intensity can also be influenced by the weather. Winterized diesel blends contain less energy, and you have no control over this. However, consider these measures to reduce unnecessary fuel use in the winter. Use a programmable cab and engine heater to speed up the warm-up cycle. Consider double shifting your machines, which could mean 1 warm-up cycle at the start of the week, instead of 1 cycle for each day worked. Use high-quality synthetic fluids that are appropriate for the season. 1 fluid spec can rarely do it all. Deep mud or snow can impair machine mobility. Consider increasing your operating hours when conditions are ideal, and/or decreasing hours when conditions are poor. You can't change the logging environment, but you can adapt to it. Understanding your energy intensity in the winter versus the summer is critical to covering your cost and making profits. In this seasonal evaluation, we found several trends with the forwarders. They consumed more fuel due to the winter effects we discussed previously, such as prolonged warm-up cycles for drivetrain components, hydraulic fluids, and engine oil, and also fought for traction in the snow. The machines produced more wood in the summer, with load size being significantly larger. And they had significantly higher energy intensity, or liters of fuel consumed per cubic meter of wood produced in the winter. Not all machines display such a dramatic energy intensity difference between the seasons, so it's important to understand what drives your energy use. In this lesson, we have learned the following. Fuel cost will continue to rise. The higher the cost of fuel, the greater the proportion of fuel cost will be on the operating budget. Choose your machines wisely, as they have a major impact on energy intensity and on your wallet. Understand what factors influence the energy intensity of your operations. Factors you can control are opportunities for process improvement. Factors you cannot control are opportunities for adaptation or change in technology. In the next lesson, we will cover how you can improve your operations through machine and productivity tracking, and how you can create an energy efficiency program to help you get a handle on your ever-rising fuel costs.